Hi everyone, good evening. How are you guys?
Good evening, sir.
So
Good evening, sir.
you did some permutations and combinations in your life, huh? Sunshine? Can you see the screen?
Yes, sir.
So today we'll study permutations. Okay, we have already done few questions based on the fundamental principle of counting. Since most of you were not present, I'm not going to revise it, but I'll just tell you what the fundamental principle of counting means. Okay, so first is principle of multiplication. Okay, I keep repeating this because it's really important. Okay, so I'll give you the explanation of the book in the way it is explained in a book. That will be like, suppose there is a work that can be done in m ways. Okay, there is a work or some event or a job that can be completed in n m ways, and after this it can be there is another job which can be completed in n ways. Okay, so how then the two jobs, how it can be completed, it can be done using m into n ways. Okay, that's called fundamental principle of multiplication. And there is fundamental principle of addition, that is, if there are two jobs such that they can be performed independently, means, let's say there is some job which can be performed in m ways, but there is another job that can be performed in n ways, but these two are not dependent on each other. Okay, it's like, first here in multiplication, first you have to cook the food, right, in order to eat it, right? So that can be one of the examples. First you will cook the food, then only you can eat. Nowadays, please don't say that, okay, we can obviously purchase it from the store or go to the restaurant. That means first you have to go to the restaurant, right? Then only you can eat the food. And let's say there are two ways, both are independent. Like, you can have the food, means you can eat, and you have to study. Let's say these are the two events. Obviously we need food for energy, but even if we don't take food, we can study, right? So these are the two kind of independent ways. So thus here we use fundamental principle of addition, that is m plus, this can be done in m plus m ways. Okay, see, whenever there is or statement in English language, okay, that time we'll use addition. And whenever there is and statement, okay, for if you have to in order to eat the food, you have to cook it. That means cook and eat, right? And here food and study, so either you can study or you can make your food. Okay, so or statement is there in English language. That's what is the fundamental principle of counting says. We have done questions based on this, and today we will start permutations. Okay, so any doubt here? So if you need any explanation, we can have it. Okay. Anything? I think so. Last class we have discussed permutation, right? And I have given you two formulas. Like there are two theorems in permutation. That is also, that must be there in your NCERT book, I suppose. Okay, so first theorem that I gave you, let's call it theorem. That will be your, if R is greater than equal to 0 and lesser than equal to n, right? That then NPR is equal to n factorial upon n minus r factorial. That's what I give. And I think Shri Kruti, you only asked me about the proof. So do we really need the proof for this? Okay, first of all, again, yesterday some of you were absent. Permutation. What's the meaning of permutation? So in permutation, it means different arrangement, different arrangement which can be made using some, depending upon the number given to us. Okay, taking all the numbers or few of the numbers at a time. At a time means That is, R is few of the numbers at a time. R can be n. Like if you write npn, that means you are arranging n numbers, and when you are taking all numbers at the same time. Okay, that is npn. Okay, we will discuss that in further. Okay. Now in permutation, I have also mentioned yesterday that order matters. Order is really important in permutation, and let's write linear order. Okay, linear order matters in permutation. Okay. So permutation can also be represented either by NPR, or we also write sometime as N P n comma R. The meaning is same. Also, sometimes it is because it is arrangement of numbers or arrangement of events. So we can also write this is arrangement. So we also write A and R. Mostly we'll be using these type of this notations. Okay. So theorem 1, it says that, okay, NPR, how we can write NPR is equal to, okay, let me give you the explanation for this first. So are you guys there, or is am I audible to you all?
Yes,
Any-
sir.
Yes, sir.
Shreya, were you there? How many of you were absent in yesterday's class? Because I'm repeating things. So can you just let me know how many of you were not present? Huh?
Sir, I guess there were like 6 to 7 people who were attending online, sir. I don't know
Okay.
who were absent.
So yesterday I have explained permutation, right? I had,
Yes, sir.
at the end I had explained. Okay. So we'll just directly go with the problem. It's just like number of arrangement of, like, let's say you have n number of places. Okay. N number of places you have. So the first place can be filled. This is the first place that can be filled using n numbers. Second place can be filled using n minus 1 ways, right? This can be filled using n ways, right? And then the next one can be filled in n minus 2 ways, right? And suppose you are filling R vacant positions. So there are total of R vacant positions. Like we have also done problem based on this yesterday, right? So this is 1, 2, 3, 4, and up to R. Okay. R can also be equal to n. That means you are taking all the numbers at a time. Okay. I will do examples based on this. Don't worry. We'll do a lot of problems based on this. So here it can be filled with n minus R plus 1 ways, right? Is this clear why n minus R plus 1 ways? You can see here also. See, if first position can be filled using n ways, second position can be filled using n minus 1 ways, and that's why rth position can be filled using n minus R plus 1 ways. Like if you substitute R is equal to 3 here. So if R is equal to 3, n minus 3 plus 1, that is equal to n minus 2 ways, right? So which is n minus 2 ways. That's why we can write like that. All right. I hope this is clear to you all. It's not a big deal. So this is what the meaning of permutation is the filling of ways. Okay, so some of the important points that we are going to see about permutation, that number of permutation of n different things taken all at a time can be written as. So I'll just write some of the important points. So the number, I think this should be there in your NCERT as well. Let's see. Permutation of n different things, or n different events also you can say. I'll just write things and different things. And you're taking all the terms, all the elements at the same time. Taken, and it is written as taken all at a time. Okay, so that means NPN, which is again equal to n factorial. Okay, that means what? If we are trying to fill 5 positions, let's say 3 positions. Okay, and we are given 2 numbers, or let's say 5 numbers we are given. 5 numbers, right? 1, 2, 3, 4, 5. These are the 5 numbers, and these are the three places that we need to fill. And you can take, you can use only 5 position, right? And NPN we have to explain, right? So 5 positions are there, and there are 5 different numbers. That means this position, and repetition is obviously not allowed. That's the meaning of permutation, is because order matters here. So this position can be filled in 5 ways. This can be filled in 4 ways. There are total of 5 numbers. So this can be filled using 3 ways, 2 ways, and 1 way. So this is your 5 factorial. So total can be filled using 5 factorial ways. Okay, that's what the meaning here it is. The second is NP0. NP0. Do you know how to calculate NP0? We already have the definition of this permutation. This definition we already have. So NPR meaning n factorial upon n minus r factorial. So this is n factorial. Sorry. Please let me know if I'm going a little fast, because we need to finish our syllabus as well. I'm just trying to give you all the points. N factorial upon n minus 0 factorial. That will be equal to 1. Fine. I don't think there is anything, fancy here. NP1 will be equal to how much? This will be equal to n, because n factorial upon n minus 1 factorial. So n minus 1 factorial will get cancelled out. Again, NPN we have already seen, right? So NPN we have already done. Let's move on to another point. Okay. So NPR, please calculate this as a question. NPR upon NPR minus 1. Please find how much it is. How much will be this? Anyone? NPR upon NPR minus 1. How much will be this? Murli, please, anyone tell me.
Doing it, sir.
N minus r plus 1.
Yeah, is this Nidhi?
Yes, sir.
How much? What is the answer?
N minus r plus 1.
N minus r plus 1. Correct. Anybody need explanation for this? It's just really simple, right? N factorial upon n minus r factorial whole divided by n factorial upon n minus r minus 1 factorial. Okay, so you can write this as n factorial we can cancel out. So this will be n minus r plus 1 factorial upon n minus r factorial. This will be equal to what?
Yes, I got the answer, sir.
Yeah, n minus r plus 1 into n minus r factorial divided by n minus r factorial. This will get cancelled out, and finally you will get n minus r plus 1. Okay, all right. So since we have the yes, and obviously I'll just write it down. NPR. Okay, you are only going to use NPR when repetition is not allowed. Okay, I've written it, but I'll just write it here also. Is not allowed. It's common sense, right? If repetition is allowed, that means it will just be n to the power of n. It won't be or n to the power of r, whatever it is, how many places it is. Like we did this problem, if repetition was allowed here, so it will be 5 into 5 into 5 into 5 into 5. So this will become 5 to the power of 5. Okay, But we are here, repetition is not allowed. So this is 5 factorial. We have done this type of problems in fundamental principle of counting. Okay, now let's start solving problems based on this. Okay, so if you have any doubt, please let me know now itself, or we will start solving problems. Okay. Let me open your, let me get your NCERT book. But before that, let's solve this first problem. Okay, so in how many ways the letter of the following word can be arranged? So I'm giving you the word equation, EQUATION. Okay, so this, so you have to find in how many ways this letter can be arranged. With meaning, with or without meaning, doesn't matter. Okay, so write down how many ways of this word can be arranged. Yes. How many letters are there total? How many letters are there?
8, sir.
8 letters are there, right? So how many ways it can be arranged?
8 factorial.
Anyone? See, there are total 8 letters, right? Total 8 letters.
8 factorial ways.
Right? So yeah, exactly. So but you have to fill all the 8 positions. 1, 2, 3, 4, 5, 6, 7, 8 positions. So first you can fill using either of E, Q, U, A, T, I, O, N. All are different letters, right? All are different letters. So either you can fill using, suppose you, any position you occupied with, let's say I, this position is occupied with I, right? That means, or let's say in this first position, always do from backside. Okay, so in this first position, let's say you can fill how many letters? You can fill 8 letters. Now since, let's say which letter you are filling, let's say you filled O here. Okay, now how many letters are remaining? There are 7 remaining. 7 here. How many? 6, 5, 4, 3, 2, 1. And you have to fill all this all these places. You have to fill, you have to use all the letters. That means you just multiply this, and statement is coming, right? That is equal to 8 factorial. Anybody is having doubt here? I think it's very clear, right? Or if you have doubt, you can please, we can do it again. Okay, second question. Okay, 8 children are to be seated on a bench. 8 children, there are 8 children are to be seated on a bench. Okay, sorry. Now first calculate in how many ways can the children be seated. In how many ways, that means arrangement of children's, right? In how many ways? In how many ways can the children be seated? How many ways? There are 8 children.
8 factorial.
Right? So eight children, they can be arranged in any manner, right? So if 8 children's, out of which if one has occupied any position, so this position can be filled using either of the 8 students or children. Now 7 are remaining, so 7 can either one can fill this. So similarly, it can fill 1 till 1 if the last one is remaining. So it will be again 8 factorial. Okay. Now the second problem is, understand this one. In how many arrangements are possible if the youngest and the eldest children sit together? Okay, how many, let's say how many arrangement are possible if the youngest okay, let's change the youngest child sit at the right side or right end, let's say right end of bench. Now tell me this one. See, there are 8 vacant positions. 1, 2, 3, 4, 5, 6, 7, 8. Right? What we are doing, and there are total 8 children. But the youngest one will always sit here. Okay, youngest one will always sit here. Right? So tell me how many ways are possible.
7 factorial.
Who is this?
Shreya, sir.
Why Shreya 7 factorial?
Because the in the right end of the bench, the youngest child is sitting, so it's not going to change.
Yeah. Okay. So that means here only that guy is going to sit, right? Only one person is possible here, right? Only one child.
Yes,
is.
sir.
And so the remaining 7 child can be arranged in 7 factorial ways, right? So 7 factorial
Yes, sir.
multiplied by 1, that will be equal to your 7 factorial. Is this clear or not? Anybody is having doubt here? See, the youngest one will always occupy this position. Okay, nobody else can take that seat. That seat is taken by the youngest one, and it's not like there are 2 youngest children. Youngest means only one can be youngest, right? So the youngest one once occupied, then there are 7 other seats are vacant. 1, 2, 3, 4, 5, 6, 7. And in these 7, the 7 children can be arranged using 7 factorial ways, right? So that's why it is 7 factorial. Okay, very good. Anybody is having doubt here? Okay, next question. Find the number of permutation of English vowel taking 2 at a time. Okay, so you have English vowels A, E, I, O, U, right? Now you have to arrange these vowels taking 2 vowels at a time. Taking 2 at a time. And verify your result. Okay, so let me write the complete question. Fine. Find the number of permutation. Number of permutation or arrangements also it can be written of English vowel taking 2 at a time. Okay. Also verify your result. Can we have the solution? See, what is NPR? What is NPR? Where is NPR? Where I have written NPR? Okay, what is this NPR? See, this is number of permutation of n events taking R at a time. Okay. Of n events or n jobs or n events, let's write n events taking R at a time. Okay. And here it means NPN means all at a time. So till now we have done problems all at a time. That means we have 5 seats. We need all the 5 children to sit there. Okay. So now solve this one. Yeah. Tell me. Shri Kruti.
Sir,
Yes, tell me this answer or how you will explain this.
20.
20. How?
Sir, substituting in NPR formula will get 20.
Okay. That means number of permutation of 5 taking 2 at a time, right?
Yes,
That's
sir.
what the meaning is. Number of permutation, or let's write number of arrangements. Arrangements taking number of arrangement of 5 letters taking 2 letters at a time. So that will be 5p2. Okay, that means 5 factorial upon 5 minus 2 factorial, which is equal to 5 into 4 into 3 factorial divided by 3 factorial. This will be equal to 20 ways. Can you write the events? You also need to verify your result, right? Can you verify your result?
Sir, yes, sir. Each letter makes 4 other combinations with other letters.
Yeah.
5 into 4.
Verify your results. Okay. So that means you have to take 2 letters at a time, right? So either you have 5 A, E, I, O, U. So either you can write AE, right? AI, AO. When you are asked to verify, that means you have to write all these. Okay, got it? A, which is left, U. Now E, EA, EI, EO, EU. Okay. IO, sorry, IA, IE, IO, IU. So which are the possible combinations that we are eliminating? That is my question actually. This so everybody knows, this so everybody can do. Which is the possible combination that we are neglecting? See here, repetition is not allowed. That means we are neglecting AA, right? We are neglecting EE. We are neglecting II, right? Because we are not repeating the this alphabets. Okay, only 5 alphabets are there, and we are not repeating it. That's why in permutation, order also matters, and repetition is not allowed when you are arranging this elements. Okay, got it? And again, O, obviously OA, OE, OI, OU. Okay, UA, UE, UI, UO. Okay, these are the possible combinations. Okay, so these are 5 and these are 4. Oh, sorry, these are 4 and these are 5. So this will be equal to 20 when you multiply. All right. Next question. Understood, or do you have any doubt here? Taking 2 at a time, meaning you understood, no? See, we are taking 2 at a time here. Taking 2 letters at a time. We are not taking 3 letters. Now, solve the same problem, taking 3 at a time and verify your result. Ashwin, can you please switch off your mic? That means you listen in class, but you don't say anything, right? Abhinav, tell me the answer. Sunshine. Hari Raghav, I haven't seen you for so long. You are not coming to academy also. Solve a web problem, taking 3 at a time. Yes, Hari Raghav, tell me the answer.
So 60, sir.
What?
60, sir.
60. This.
Yes, sir.
Okay, anyone else?
So 60.
60, 60.
60, sir.
Okay, how? What you are finding? So number of arrangement of 5 letters taking 3 at a time, right? That means you are finding 5p3, isn't it? That's
Yes.
what you will find, no?
Yes, sir.
That means 5 factorial upon 5 minus 3 factorial, isn't it? Or 2 factorial. That means this will be equal to your 5 into 4 into 3, right? So that will be 60. Okay. So can you verify your result? It will take a lot of time, right? So let's not do that. Understood? No, if you have to verify, that means this is the method that you can use. That means verification. Okay, let's do another problem. Hopefully that is clear. See, whenever in exam you are writing, you must write this statement. Okay, this statement is really important. That number of arrangement of 5 letters taking 3 letters at a time. That's what you need to write, and that is written as 5p3. Okay. So this is 3, question number 4, question number 5. Okay. Okay. Find the number of ways in which 8 boys and 5 girls can be arranged in a row so that no 2 girls are together. Okay, very good. Find the number of ways in which 8 boys and 5 girls can be arranged in a row so that no 2 girls are together. Find out. By the way, this question is not valid for both biology. They will always sit together no matter what. Right? Huh? Huh, bio? Both bio are present or only one bio is here? Okay. No answers. All right. So there are 8 boys in the class and 5 girls are there in the class. How can we do that? Say first find out how many total place. Okay. First do it yourself. Try it yourself. Anyone, how you will proceed for this problem? This is a little different from what we have done till now, right? See, anyone, please, Nidhi, Hari.
Sir, we find the total number of ways to arrange and subtract 5p2 ways from it.
Is it? Will you get the answer? Okay, anyone else? Yeah, Nidhi, try to find out using your method. Do it and find out, tell me the answer. Anyone else? Shreya?
Sure, I'm trying.
Okay. See, I'll give you a hint, okay? See, first thing, boys can sit together, right? It's just like two girls must not sit together. That means in between two girls, there must be a boy. Okay. So let's first make boxes, these places. Okay. First thing, I'll erase some boxes. Okay, don't worry. I'm drawing too many boxes. Okay. So there are 8 boys. 8 boys can be arranged in 8 factorial ways in 8 places, right? There is no there is no restriction for boys to sit together, right? So let's say if a boy is here, okay, and in the middle there must be there has to be a girl. Okay, so boys. There are 8 boys, total 8 boys, so that can be arranged in 8 factorial ways. Sorry. Boys can be arranged in 8 factorial ways. Is it or not? Okay,
Yes,
now
sir.
there are 9 places. Let's say these are the places. 1, let me use different ink. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the girls, possibly the girls can sit in these places. There is no other possibility for a girl to sit, because if you move 2 boys together, let's say here, if you move 2 boys together, then 2 girls will be together, right? So that is not how we can arrange it. So B, and here it will be a boy, and these are just possibilities. So boys can be arranged in 8 factorial ways, and girls, like in 9 places, how many? And there are 5 girls, right? So in these 9 places, 5 girls can be arranged using how many ways? 9 here in 9 places, either any of the 5 girls can sit here, any of the 4 girls can sit here. So 9 into 8 into 7, sorry, into 7 into 6, right? 1, 2, 3, 4, 5 girls into 5. So these are the methods in which a girl can sit. 5 girls can sit on 9 places. So this will be how much? Just find out this number as well. So, I don't know how much this number is going to be, but it's important to understand that there are 9 places, right? 9 empty places for a girl to sit, and there are 5 girls. So the first girl can sit in 9 ways. Second girl can sit in 8 ways. Third girl can sit in 7 ways. Fourth girl in 6 ways. Now there are 5 places remaining, and only 1 girl is there, right? So that girl can sit on 5 places. And then boys, either these 3 boys can be together, or it doesn't matter. If suppose girls are occupying this, and this place, so that means these 4 boys will sit together. Okay, so boys can sit any way they want, but girls must not be allowed to sit together. That's what the question is. So this number is 9 into 8, 30, 72, 7.
Sir, 4620.
15,120, sir.
15,120 ways. Okay, and this is 8 factorial ways. See, in exam also, unless it is asked, you are not supposed to do all the calculations if it is not asked. Okay, and total number of arrangement will be just multiplies this 8 factorial into this 15120 ways. These are the total ways. from the fundamental principle of counting, right? This is an and statement. Boys and girls must be sat, right? Matlab, they have to sit. They have to sit. It's not like 5 girls, they can skip the class or something. They have to sit in a row. Okay, that means it's an and statement. And fundamental principle of multiplication says, if there are an event that can be arranged in some ways, like 8 factorial ways, m ways, and another event that can be arranged in n ways, so total number of ways of arrangement will be m into n. So that's what we are doing here. Okay, is this problem clear to you all? Because these type of problems will be there mostly. Is anybody is having doubt in this problem? I can explain it again, or we can go ahead and solve more problems. Okay. Is this thing clear why it is 8 factorial ways and why this is 9, 8, 7, 6, and 5? Nidhi, is it clear to you? Shreya? Shri Kruti,
Understood, sir.
Yes, sir.
what happened to you, Shri Kruti? Why your volume is so low? Okay, anyway. Biology 2. You're not saying anything. Ashwin, Sham, you guys are there? Murli, is it clear?
Yes, sir. Understood, sir.
Okay. Okay, let's do another problem. So write down 6 candidates are called for interview. Write down. So 6 candidates are called for interview. Write down the complete question. To fill 4 positions or 4 posts. Okay, so 6 candidates are called for interview to fill 4 posts in an office, assuming that each candidate is fit for each post. Okay, so we have to assume that all the 6 candidates are, they are good enough to fill all the 4 positions. Okay, determine the number of ways. Number 1, in which first and second post can be filled. First and second post can be filled. We are doing permutation, that means that's why I said arrange. Okay, so I'll repeat the question one more time. 6 candidates are called for interview to fill 4 posts in an office, assuming each candidate is fit for each post. Determine the number of ways in which, so first and second post can be filled. It's a really simple problem, right? We have done it. See, right now you have, yeah, anyone tell me the answer.
Sir, is it 30, sir?
30, how?
30, sir.
Sir, 6 into 5 because it can't be repeated.
Yeah, it can't be repeated. That means is the number of permutation of 6 candidates taking 2 candidates at a time, right?
Yes, sir.
So it's number of permutation or arrangement, whatever you want, you can write. Permutation of 6 candidates taking 2 at a time. You are this meaning is getting clearer, right? To taking 2 at a time, taking 4 at a time. It will come with solving problems. Okay, don't worry. I know sometimes it feels like, okay, what is going on, but just keep solving problems, you will understand it. So 6 into 5. Okay, for those who don't know how to solve permutation, so 6 factorial upon 6 minus 2 factorial. So this is 6 into 5 into 4 factorial upon 4 factorial. So this will be equal to 30. Now the second question is, all the 4 posts can be filled. All 4 posts can be filled. Find out. So there are 6 candidates and 4 posts. 1, 2, 3, 4 posts are there, and there are 6 candidates. Sorry. Okay. Yes, anyone? Okay, let me ask. Hari Raghav or Hari Haran. You tell me. Hari Raghav told the last answer. Yes. Hari Haran. Yes, sir. Hari, are you there or not?
I'm here,
Tell me
sir.
your, yeah. See, there are 4 posts. These are the 4 posts. 1, 2, 3, 4. And there are 6 candidates. So how can they fill all the 4 posts?
Using the permutations formula, sir, we can do 6p4, sir. So it's
Find out how much is
factorial.
6p4.
Yeah, okay, sir. Shall I do it, sir?
Or you can just this position, the first position can be filled by any of the 6 candidates. Second
Yes, sir.
position can be filled by any of the 5 remaining candidates. Third position can be filled by any of the remaining 4 candidates. And the last position can be filled by any of the 3 candidates. How much is this? This is your 30 and this is 12. How much will be this? So this will be 2, 3, and
630.
it's going to be 360. Yeah. 360. Got it? Anybody is having doubt here?
No, sir.
Okay.
No.
I'll move ahead. Okay. Okay. Next problem. Okay. 3 married couples are to be seated in a row. Write down. 3 married couples are to be seated in a row, having 6 seats in a cinema hall. Wow. Okay. Whew. See, online classes, I have to write all that, everything. Seated in a row, having 6 seats in a cinema hall. If spouses are to be seated next to each other. Okay, so the couple will sit together. Seated next to each other. So in how many ways can they be seated? Find out. In how many ways find out?
6 ways, sir.
6 ways. How? Explain. Explain. See,
Sir, I don't know whether it's right.
whether you don't know whether what.
I don't know whether it's right, sir.
I just explain. It's fine. If it is right or not right, doesn't matter. You tell me your explanation.
Sir, they are going to sit with each other, sir. So I took it as one couple one couple together, sir. So it's going to be 1, and I took it as 3.
Okay.
So 3, 2, and 1, and if you multiply, you'll get 6.
Okay, you are missing slightly. You are missing something. Okay, almost
Sir,
you
is
are
it 120?
120. I don't know the answer. Let's solve it. Okay, so 3 married couples are to be seated in a row. Okay, so number of couples are how many? Always start questions like this. So 3 couples are there, right? Like AB is a couple. CD, EF. Okay, they are the couples. Like electric field and magnetic field, right? Have you heard? Acha, you have read this in 10th standard, right? In 10th standard also it was there. Because electric field cannot change in electric field is always equal to change in magnetic field. right? You know this, right? This is Maxwell's equation. Have you solved this equation? No? This statement, so at least you must have heard, no? If change in electric field will always produce a change in magnetic field, and change in magnetic field will always have a change in electric field, right? Okay, let's move on. So number of ways of arranging three couples. Now, first, these are the three couples. 1, 2, and 3 couples. So these three couples can be arranged in how many ways? Three factorial ways, right? Let's say this is X, Y, Z. X couple is having AB, Y couple is CB, and Z couple is EF. Okay, so they can be set. They can set like X, Y, Z, or Y, Z, X, or what? X, Z, Y, right? Or Y, X, Z, right? And what else? Now Z, X, Y, Z, Z, Y, X. So these are the ways, that means 3 factorial ways. These couples can be arranged, right? Any doubt here? Let me write. The couples means X, Y, Z we are talking about, okay? These two are together, okay? So the couple can be arranged in 3 factorial ways, right? So that is 6 ways. These couples can be arranged. Okay, we have also written all the 6 ways how they can be arranged. Okay. Now, all couples is having two, a husband and a wife, or a girlfriend and a boyfriend. Okay. So A, B. So that means they can be arranged in 2 factorial way. Either it can be, see, when you are writing X, X can consist of either AB or BA, right? Isn't it? Yes or no? This is also one of the arrangement, right?
Yes, sir.
Yeah. So number of ways. Number of ways of arranging couple or spouses, that's right. Okay, that means they are not girlfriend, boyfriend, they are married. In each couple is 2 factorial ways. So that will be equal to 2. 2 into 1 is 2, right? Now what? So now how many combinations are possible? Yeah, tell me. See, each couple can be arranged in 2 ways, right? So that means these couples, X can be arranged in 2 ways, Y can be arranged in 2 ways, Z can be arranged in 2 ways. That means 2 into 2 into 2, right? So they can be arranged in 6 ways. And there are also 6 ways of arranging couples. So total it will be. So
Sir,
6,
2 into 2 into
sorry,
2
it is
will be
8,
eight.
not, sorry, my mistake. So 6 into 8, so that will be equal to 48 ways. Is this thing clear or not? Anybody is having doubt, please tell me. Because see, these are the easy problems that we can understand. Okay, all the problems are like this only in permutations. So if we can even understand or have an idea of these problems, we can solve all the problems. Okay, getting it? Yes.
Yes, sir.
See, I'll repeat again. So there are 3 couples. Okay, there are 3 couples. So 3 couples can be arranged in 3 factorial ways, right? That is 6 ways. These ways I've already written. Now each couple can be arranged in 2 factorial, either AB or CD or DC. Now either it can be EF or FE, right? 2 factorial ways. So again, so this can be done using how many ways? 8 ways it can be done. So 6 into 8, that will give you 48 ways total. Understood? Okay, so we'll stop the class here. And again, tomorrow also we'll solve problems based on permutations. Okay, we'll finish permutations tomorrow. Hopefully, and tomorrow, after tomorrow, you can solve your exercise 7.3. Okay, there are permutations of circular permutation and those things are there. So we'll see you tomorrow. Okay, see you. Bye.
Thank you,
Thank you,
sir.
sir.
Thank you so much.